Hey guys, today's lesson is on writing and solving proportions. Again, starting with a definition today of what a proportion is. It says a proportion is an equation that states two ratios are equivalent. Well, we talked about ratios in our previous lesson. Okay, ratio is just a comparison of two numbers, so something like a fraction. So that's what we're going to be doing today. A proportion is really just two ratios that are equal to each other. And because it says that it's an equation, well, an equation means that there's going to be an equal sign involved, all right? So we're going to simply come up with two fractions, two ratios, that are equal to each other. For instance, 2/3 equals 8/12. Well, if this is really true, if 2/3 does equal 8/12, then this entire thing is what we call a proportion. 2/3 equals 8/12 is what we call a proportion. Now, I'm going to show you that these two things are equal, because if they are equal, this 8/12, we should be able to reduce that, and it should become 2/3. So if I divide both of those, the numerator and denominator, by 4, 8 divided by 4 is 2, 12 divided by 4 is 3. So you'll see, yeah, 8/12 really is the exact same thing as 2/3, and that is what makes this thing a proportion. Okay, it's two ratios that are set equal to each other, but they have to be equal ratios. All right, if they don't equal each other, then they don't end up being a proportion. We can't claim that they're equal if they're actually not. Okay, another thing that we're going to say is true here. I'm going to rewrite this exact same fraction. We're going to write 2/3 again, 2/3, and we just showed that it's equal to 8/12. Okay, we proved it by reducing the 8/12. We know these two things are equal. Well, one other thing that we're going to say is going to be true is that cross products of a proportion are always going to be equal. We're going to write this down here. Cross products are always equal. Cross products are always equal. If something really is a proportion, if these two things are really truly equal, 2/3 and 8/12, then their cross product should be equal. Here's what cross products mean. A cross product is when you multiply diagonally. If I do 8 times 3, that equals 24. Well, then the other cross product should also equal 24. So if I take the other diagonal and do 2 times 12, I had better get 24. And sure enough, 2 times 12 is 24. So because these two things are the same, that's another way to prove that these two things really are a proportion. All right, if I choose two things that are not the same thing, and I'll try to draw a little different one over here. Things that are not a proportion, not a proportion. Okay, just to show you quick, I don't even care if you write this down. Well, let's take something easy, like 1/2, and let's try to claim that that is equal to 3/10, which I know 1/2 is not the same as 3/10. But if you check their cross products, 2 times 3 equals 6. Okay. Well, if I do the other cross product, 1 times 10, that equals 10. Well, the 6 is not the same. So that's a way to prove that these are not a proportion, and therefore we cannot claim that these things are equal to each other. We can't put the equal sign in the middle there because those two things are not equal to each other. So that's one way to prove that something is a proportion or not. Okay. Now, what's going to happen today, as you can see here, is we're going to be given a proportion. But what they're going to do is they're going to leave out what one of the numbers are. They're going to say, what number does that have to be? What does that numerator over the 18, what does that have to be so that this really is a proportion? There's only one number that x can be. Anything else makes it not true, makes it not a proportion. Okay, so I'll do example 1 here. Actually, I'll do both of these. What we're going to do here is this. One way to look at it is if you just look at the denominators and say, well, what if I took 5, 6 and I underreduce it? What if I want to change it into something over 18? Well, what do I have to do to the 6? Well, if I take the 6 and go times 3, that gives me 18. Well, then what that means is I have to multiply by 3 on top. 5 times 3 is what gives me x is going to have to be 15. Okay? And we can go ahead and check that. We can see if that works. If I take 5/6, and that's supposed to equal, now if x is really 15, that means it should be 15 over 18. We can check the cross products. We can do 5 times 18. If I pick up my calculator and do 5 times 18, I get 90. Well, then when I do the other one, 6 times 15, it better be exactly the same. 6 times 15, and using my calculator, sure enough, that does equal the 90. So yes, this works, so I know that x has to be 15. Okay. Example 2. Now when I look at this one, all right, again, I know both denominators, so I might say, well, how do I change 12 into an 8? Well, that's kind of tough to do. If I wanted, I could go this way too and say 8 times how much equals 12. But again, it doesn't go into there a perfect amount of time. So one trick that we might be able to do is this. Well, I know that this is just a ratio. And any ratios can be simplified. Well, I can reduce 2/8. So if I rewrite this, it's going to be x over 12 equals, and if I reduce the 2 over 8, I'm going to get 1/4. Well, now look how easy it is to do, because I know I can change 4 into a 12 by going times 3. So then on top, if I go times 3, I figure out that x has to be 3, because 1 times 3 is 3. Okay? If I go ahead and plug that in for x, you could check to see if it works. Okay? 12 times 2 is 24. 3 times 8 is 24. So I know it works. X is going to equal 3. So those are a couple ways to solve proportions. Okay? Now what I would like to do is do those exact same two problems again. So if you see on this page, I have example 1 and example 2 written down again. They're the exact same problems that we did. But you'll see right in blue here I say another way to do example 1 and 2. There is another way, and this is what you guys are going to love. Okay? Cross, multiply, and divide. Okay? And really what this means is this. Because I know that cross products have to be equal, when I do 5 times 18 and get 90, I also know that 6 times something has to equal 90. Okay, well, because of that rule, what ends up working in is this cross, multiply, and divide rule. And what that means is that we need to do this. Whichever two numbers that are diagonal from each other we know, like the 5 and the 18 are diagonal, I know both of them, I'm going to go ahead and multiply those together. That's what we mean by cross multiply. Okay, the diagonals are what we're cross multiplying. Diagonals. Okay, 5 times 18 is 90. Okay, and then it says divide. Well, we divide after we get that 5 times 18 is 90. Then we're going to divide by that other number that we haven't used yet. We haven't used the 6. So now I'm going to do 90 divided by 6. And then that's what's going to give me x has to be 15, because 90 divided by 6 is 15. So you're always going to multiply the diagonal, divide by that third number that's left. Okay? If you guys want to pause the video and try example 2 on your own, go right ahead. Okay, you're back. The last time we did this problem, we took the 2 and the 8 and reduced it to 1 over 4. And then we did 4 times 3 is 12, so 1 times 3 is 3. So I know the answer is going to be 3, and that's one great way to do it. But I want to try using the new rule here, the cross, multiply, and divide. So what I'm going to do is take the two numbers diagonal that I know, the 2 and the 12, do 12 times 2 is 24. Okay, and then I'm going to divide by the 8 there and do 24 divided by 8 to give me x has to be 3. Okay, so cross, multiply, and divide, super, super easy to do. All right, here's a little tougher one for you. Solve the proportion. What I want you guys to do is just pause the video and think about it for a second. See if you can come up with a good way to try this. And then I'll come back and show you another way, or maybe the same way. Okay, pause the video. Okay, you're back. I'm going to rewrite this problem. If I write this, again, as 4/5 equals, and let's just say it's just x over 10. Well, watch what we would do here. What we just learned is to cross, multiply, and divide. I would do 4 times 10 is 40, and then that 40 divided by 5 is going to give me 8. I would know that x is going to have to be 8. And go ahead and cross multiply again. The 4 times the 10 gives me 40. The 8 times the 5 gives me 40 as well. So I know that x is going to be 8. Okay, if that was the problem. However, that's not the problem. But when I go back to the tougher problem here now, it's really no different. Okay, I know these three numbers right here, the 4, the 5, and the 10. What I don't know is what that is. Okay, but if I treat that as just one single number, okay, I can solve this just the same. Let's cross multiply and divide the other three. So if I do 4 times 10, just like I did above, that's 40. And then I do 40 divided by 5. That's going to say 8. What that means is this number up here, okay, is going to have to be an 8. I know whatever ends up being in the parentheses has to be an 8. Okay, now 8's not my answer. That's just telling me when I do some number minus 12. When I do x minus 12, it had better equal 8. Okay, so then if I want to use algebra, I can go ahead and add 12 to each side, and you're going to figure out that x is going to equal 20. Because if I plug 20 in place of x, 20 minus 12 is what gives me the 8 that we said it should be. So we're going to come up here and say that x equals 20 for our final answer. Okay? One last type of problem. So now that we know how to solve proportions, doing cross, multiply, and divide, now we're going to have to set up our own. Okay? So that means we're going to have to set up, okay, we're going to have two big fraction bars with an equal sign in between them. We're going to have one ratio on this side. We're going to have one ratio on this side. And those two things are going to be equal to each other. So example 4 says, yesterday you rode your bike 18 miles in 2.5 hours. Today you plan to ride for 3.5 hours. If you ride at the same rate as yesterday, how far will you ride? Okay, well, since I know that these two things here are going to be ratios, okay, the first thing that I want to do is find a ratio that's in the problem. Okay, so it says yesterday you rode your bike 18 miles in 2.5 hours. Well, that seems like a ratio to me. Okay, it's a comparison of two numbers in different measures. 18 miles compared to 2.5 hours. Okay, so there's our first ratio. Now, on the other half of our ratio, I have two spots left. Well, I have to know one of these two, either the numerator or denominator, and then one of them is going to end up being a variable. All right. So when I look back up in my problem here, we should be able to come up with one other piece of information. It says today you plan to ride for 3.5 hours. Well, there's our other number, 3.5 hours. All you have to decide is that 3.5 supposed to go on top, or is that 3.5 hours supposed to go on the bottom? And I'm going to tell you this. The whole key to setting up proportions is that your labels have to match. If hours are on the bottom over here, they have to be on the bottom over here. If miles are on the top here, it's going to be miles on the top here. Okay, so you set them up so that they match each other. So there's the setup to our proportion. All right, we have 18 over 2.5 equals, we'll call that x. We don't know how many miles we're going to ride the second day. Okay, now that we have it set up, let's go ahead and cross multiply and divide. So we go ahead, and since the diagonals that we know are 18 and 3.5, I'm going to go ahead and do 18 times 3.5. And on my calculator, when I type in 18 times 3.5, I get 63. Okay, and then that 63 then has to be divided by the 2.5, and 63 divided by 2.5 tells me that x is going to end up being 25.2 miles. Okay, and I know it's miles because we're looking for the numerator there. Okay, so that's the key to setting up a proportion, is to make sure that the numerators, the labels match, miles and miles. On the bottom, the denominators match, hours and hours, and that way you're home free. Okay, that's our lesson for today.